Okay, linear functions and models is a couple of sections I think you're going to be able to breeze through. Probably very familiar to most of you. Linear functions, anything that can be written in the format f of x equals mx plus b. M is the slope of the line and b is the y-intercept of the line, the point where the line crosses the y-axis. Graphs of linear functions are straight lines, and the domain and range are usually both all real numbers. There are a couple exceptions to that. A function such as y equals 2 or f of x equals 2, that is a function with a slope of 0. Graphically, it's a horizontal line. And the domain is still all real numbers, whereas the range is actually simply the number 2. And then also, there are some applications of linear functions where the domain and range are not all real numbers because only certain numbers make sense to the application. For example, in some story problems, negative numbers don't make sense. Graphing something that's in the slope-intercept form is very convenient. For example, if we look at y equals negative 1/2 x plus 5, the y-intercept is 5, so we can locate 5 on the y-axis. The slope is negative 1/2, which means a rise of negative 1 and a run of 2. So starting at the 5, we can count down one step, rising negative 1, means falling 1, and then running positive 2, down 1 over 2, down 1 over 2, and we get our graph of the linear function. Another way to sketch is by intercepts. Again, an x-intercept is the value of x when y is 0, the point A0, and a y-intercept is the value of y when x is 0, the point 0b. And I just made my example a little more complicated looking here. So 230x plus 340y equals 60. This is a standard form of linear function, which is not the useful form. So looking for the y-intercepts, if we let y equal 0, that will wipe out this entire term, leaving us with 230x equals 60. Easy to solve for x. 60 over 23 would be a number just a little bit smaller than 3. So it would be about here on the x-axis, or x-intercept. And then if we let x equal 0, solve for the y-intercept, we get 60 over 34, which is a number just a little smaller than 2, which would be about here, and we can do a quick rough graph of the function. Slope of a line is a formula you're probably familiar with. I usually use m equals y2 subtract y1 over x2 subtract x1, and you could just as easily use m equals y1 subtract y2 over x1 subtract x2. Really what we just need is the change in y over the change in x. Just be consistent in which coordinate is subtracting which coordinate. Once we have the slope, we can find the equation of a line with the point slope formula. Y subtract y1 equals m times x subtract x1. And these should both be formulas you're familiar with. So looking at a couple examples here, say that we have a line passing through the point negative 2, 5 with a slope of 4. X and y in our formula here stay as letters, whereas the y1, the m, and the x1 all get replaced by their respective values. x1 is negative 2, 5 is y1, and m is 4, and we can simplify to end up in slope-intercept form. Now in this example, we're just given 2 points. We're not given the slope, so the first thing we need to do is go find the slope. Using our slope formula, again, I'm doing y2 subtract y1, x2 subtract x1. You would get the same result if you use y1 subtract y2 and x1 subtract x2. Either way, we should get a slope of 3. And I always think it's a good idea at this point to go ahead, plot the 2 original points, just a rough graph here, and see if it looks reasonable to have ended up with a slope of 3. And that can help me catch those silly negative sign errors that I'm always making before I get too far into the problem. Once I'm satisfied that my slope looks pretty reasonable, then I can take the slope in either of the 2 points and put them into my point slope form. Of the 2 points, I chose to use 3 and 5 because I had fewer negatives and fewer possibilities for making sign errors. We'll get the same result if we had used negative 1 and negative 7 for x1 and y1. Okay. Parallel lines have are 2 lines with the same slope, so m1 equals m2. Perpendicular lines, the slopes are what we call negative reciprocals of each other. So if you took one of the slopes, flipped it over, and changed the sign, that would give you the negative reciprocal. Okay, so let's look at an example. We want to find the equation of a line passing through the point negative 2, 5 and is perpendicular to this line, y equals negative 3/4 x subtract 3. So this line has a slope of negative 3/4. To be perpendicular, the slope would be a positive 3/4. So we're going to change the sign from negative to positive and flip it over numerator and denominator to get positive 4/3. So we can put in our slope, and then we were given the coordinates of a point, negative 2, 5, and simplify to get the equation of the line. And to find an equation of a line parallel to the given line through a point, this one's a little trickier because our line's not in slope-intercept form. So the first thing I'm going to do in order to find the slope is rewrite it in slope-intercept form, which means solving for y. So I can subtract the 3x, divide by 4. So the original line I was given, written in slope-intercept format, is negative 3/4 x plus 2. So if I want a parallel line in this case, I want to use the same slope. So I use the slope of negative 3/4 and the point that I was given, 3, negative 4. It's a lot of 3's and 4's in this example. Sorry about that. So you can plug in the slope, plug in the x, plug in the y. Always be extra careful when you're subtracting negative numbers. Just real easy to lose one of those. And then we can simplify. Okay, so this is a special case. Think about this. What would be a line perpendicular to y equal 3 and going through the point 1, negative 2? And for me, sketching this situation out really helps me keep track of things. So I'm going to locate the point 1, negative 2 is down here. And then the original line given y equals 3 would be here. So if I want to be perpendicular to the line, I want to intersect it at 90 degrees, and so that's going to be a vertical line. So a vertical line is perpendicular to a horizontal line. And if that line's going to go through the point 1, negative 2, its equation is going to be x equal 1. So to be perpendicular, that would be x equal 1. And then just to throw in a bonus question, if you wanted a line to be parallel and going through that point, that would be the line y equal negative 2, the green line over here. Okay, application, find a linear model for this situation. Say 10 credits at a particular college cost $2,600 and 14 credits cost $3,500. Essentially, we'll be given 2 points. We have an x value, y value, and x value, y value. We can find the slope. Pick one of the points to plug in for x and y, simplify. And the slope in this case, the 225, that's the cost per credit. So we got 900 credits for $900 cost us 4 credits, $225 is a cost for a single credit. And the y-intercept is going to be what the fees are at this particular college. So no matter how many credits you have, you're going to pay that flat fee of $350. And then if we want to calculate how much 16 credits cost, we can substitute it into the equation and simplify for the total tuition for that term. And here's just something to be thinking about. Activity 1's going to be coming up soon. And in Activity 1, you have to find a data set that can be modeled by a linear function. So you can find something out of one of your other textbooks, something out on the web. You can collect your own data, conduct an experiment. But you want to be looking for something where you've got 2 variables that represent a linear relationship with each other.